Hello, my name is Maverick Collins. This is my video submission for the graph algorithms assignment in CST-201, data structures and algorithms with Professor Woodward. And in this assignment, we are tasked with building a script that would detect the number of cycles within a given graph and spit out their weight for each cycle. So we were given this graph here. This is given to us in the assignment description. This is my main driver. So we'll go ahead and run it. So I'm gonna clear it and now run it. So here we go. It ran through the graph here, had 3 cycles, so 22 comparisons, and we're using a depth first approach, similar to the Bellman-Ford algorithm we did for the coding challenge. And you can see it did 9 exchanges within that depth first traversal. And each of those cycles had a weight of 5. So here's the algorithm here. We could see we had a class for edge and cycle. So as it's going through, it's calculating the weight of each cycle, and it's using a list to, find the minimum amount of cycles within the graph. And it goes through and compares each of those nodes within that cycle. So if it goes depth first. If it sees that one of those two numbers is out of whack, it'll swap them and it will continue. And here's the rest of my code. I had to use like I said, I used all resources, and I used a lot of the code we used for Bellman Ford, along with some of the code for the, what's it called? Floyd-Warshall, and a little bit of Dijkstra's, kind of Frankenstein them together to develop this and put them in weights. And I had it going for the Star Wars one too, just as like a test case, but I felt that was a little too busy. Didn't want to uh, confuse you guys looking at it, but yeah, this was a really challenging assignment. Did not enjoy it, and but I learned a lot about Dijkstra's, Floyd-Warshall, Bellman-Ford, and how we analyze. Oh, the time complexity. So the time complexity for this one is going to be big O. What is it? So for the Bellman-Ford, I believe it's big O to the vertices factorial, if I'm remembering correctly. And this one is a little more complex than that. I had some help, and I believe the time complexity is big O of vertices times the vertices plus the edges factorial. So it's very, very heavy on the resources of the machine. But we have a working output here for each cycle, had a weight of 5, taking advantage of some of those negative nodes there. -4 really assisted in that. And that's my solution. Thanks for watching. See you in the next one.